So let's look here at extrema on an interval, okay? Now extrema, you can kind of see in the root of that word, you can see extremes, okay? So we are looking at the extremes of a function within a certain interval. And when we're talking about extremes, we're specifically talking about maximum and minimum that doesn't have an A in the middle. Minimum points. Okay? Now, in this lesson here, we're going to look at how to test, or what points you need to test. We're also going to expand our previous definition of the critical number or critical value. So let's look at this first one here, and in these examples, we actually have the sketch with labels to the side, so we could actually tell what the answers are here already. But we're going to go through the algebra and the calculus here to prove those answers and to find them if we didn't know anything about what this graph looked like or whatnot. Okay? Now, we're also going to consider the difference between what's called the absolute maximum or minimum and the relative extrema. Okay, so we'll do all this first and then we'll talk about those terms when we get there, okay? So first of all, if I'm looking to find critical numbers or critical values of f of x equals 3x to the fourth minus 4x cubed on the interval from -1 to 2, what would I do first? Take the derivative, okay? Guys, that's pretty much your first step on everything right now, okay? Take the derivative. So, f prime of x is 12x cubed minus 12x squared. Okay? And then what? No, don't do it again. Very good. Yeah, Melissa. We're going to make this equal to 0 because those critical numbers up to this point, we're understanding that those are when the derivative is equal to 0. All right? We're going to expand that a little bit today, but for this example, that's a sufficient definition. So we're going to set this equal to 0. We're going to factor out a 12x squared, and we got 12x squared times x minus 1. So our critical numbers are when x equals what? 0 and 1. Yep, 0 and 1. Okay? Now, you'll notice here this little table, this isn't going to be given to you every time, but this table does have places for two critical numbers, one at 0 and one at 1. Okay? So what we're doing here is the process for trying to find the extrema on an interval. Okay? Now, this is where the understanding comes between a relative max or min and an absolute max or min on an interval. Okay? The relative extrema is the max or min in a general neighborhood, okay, or around a value. In other words, you can see over here on the left where it comes down to 1, -1, and then it starts going back up. It wouldn't matter what anything else what happened anywhere else on this function. That little dip where it was going down and now it changed direction, now it's going up, makes that a relative minimum. Okay? You can have more than one relative minima or maximum on a graph. Okay? However, what we're doing here when we're looking for the extrema on an interval is we're looking for the absolute maximum or minimum on that interval. So while this might be the minimum here, I might have had something like this, where this went down over here on the endpoint, and that wasn't the actual minimum of the function on that interval, okay? And we saw this before, you know, when we had, say, a cubic function like this. You had a maximum here, but that was a relative maximum because over here it went up to infinity. So the absolute max was infinity, okay? Here we have a minimum, but over here it goes down forever. The absolute minimum is negative infinity, okay? Because we're dealing with a specific interval, we actually will check, say, the endpoints of that interval to see if that endpoint might be higher than what the relative max was. Or maybe that endpoint is lower than what the relative min was. Okay? So that's why this table over here has listed the left endpoint, which in this case is -1, and the right endpoint, which in this case is 2. We take that straight from the interval up here. Notice it's a closed interval too, by the way. Question, Harrison?
Could you have a plateau point within the...
There could be a plateau point in here. In fact, it looks like 0, 0 is a plateau point. Looking at the graph. That would not be a max or a min, though.
But after 0, 0, it doesn't go up, right?
No, it just levels off and then continues to go down.
Yeah, but is it maximum? Is it extrema?
No, it's not.
Okay.
It's not. Oh, yes.
You said that the interval is the absolute extrema, so is that like just between those numbers, or are you saying the absolute
Yes.
of the whole function?
No. When we're finding the extrema on an interval, we're finding the absolute max or min on that interval. Okay? So it may or may not be one of our relative extrema, but it is on that interval. Okay? So now when I'm trying to find what these are, I'm going to plug in different values of x. What am I going to plug them into? Okay, why? Why would I plug it into the derivative?
When you plug the min derivative, then it would be 0.
Okay, if I plug 0 and 1 into the derivative, I'm going to get 0. That's how I got those in the first place.
We're not going to plug them into derivative.
Okay, what would I plug them into then?
Normal function.
All right, you're saying plug it into the normal function
Yeah.
because what are we looking for here, guys?
For y point.
The y coordinate of a point on the function, right? So if I want a point on the function, I'm not going to plug it into the derivative, I'm going to plug it into the function, okay? So, here, and guys, I made a big deal of that because that's one of the most common, easy to avoid mistakes that people will make. They're trying to find a point and they just plug it into the derivative and they wonder why they keep getting zeros. But for a lot of them. Okay, so here we're plugging this into the function, and when we do that, we get 3 plus 4, which is 7. Okay, and actually you can see that point, we can confirm that that point over there is on the graph, -1, 7. Okay, and then we plug in 0. F of 0 is 3 times 0 minus 4 times 0, so that's 0, and that point is there. Okay? And then we plug in 1, f of 1, and we get 3 minus 4, which is -1, so that confirms this point here. And then finally, we plug in 2, f of 2, and we get 3 times 16, which is 48, minus 4 times 8, which is 32. 48 minus 32 would be 16. So that confirms this point right here. Okay? Now, what we're saying here is that we're recognizing that the only places those extrema could be are either at relative max or mins or at the endpoints of the interval. That's what we're saying here. So that's why we're only testing those points. Notice in this case, we're not learning anything about the shape of the graph. To do that, we would be plugging stuff into the derivative to tell increasing or decreasing. Here, all we care about are the points themselves. All right, so where would be our maximum on this interval?
16.
Yeah, okay. This is the max value of f. And 216 is the max point. Okay, so this is really what we're looking for, the actual point. Because an extrema is a point. So please don't just put 16. Don't just say it's at 2. Make sure that you state that it's the point 216. Alright, does everyone understand that? Okay. Alright, and then what's our minimum? Okay. It's the 1, negative 1. Okay? The min value of f equals negative 1. The point 1, negative 1 is the min point. Okay? Alright, so those are the extrema. And for polynomial functions and stuff like that, you know, this is really all we have to do. Find those critical numbers by setting it equal to 0, and then check the endpoints as well. Okay? But here's where we need to expand our understanding of what a critical number is. Because critical numbers are not only when the derivative equals 0. Alright, so here we have an expanded definition. By the way, those guidelines are what we just did. Okay? That's the process that we just did. You can use that on every one of these. Okay? But let's look at our definition of a critical number. Alright? Let f be defined at c. Okay, so first of all, a critical number has to be a value of x that the function is defined at. Okay? Now, if f prime of c equals 0, that's the kind we've already dealt with. Or, this is the new part, okay? If f is not differentiable at c, okay? Then c is a critical number of f. So how do I tell if it's not differentiable at c? Okay, if it's not continuous, huh?
But then it is not defined
Okay.
sometimes.
Now, here when we use the word it, we need to make sure we understand what we're talking about. The f or f prime, okay? F prime can be not continuous, and f still is continuous, alright? So f, now notice here, it doesn't even say that f has to be continuous. It just says f has to be defined. So there could be a jump. And if there is, you know real quickly that it's not differentiable. Okay? But remember, continuity is one way that you can tell if it's not differentiable. Okay? So f is not continuous. What's another way of telling if it's not differentiable?
Sharp change in direction.
Okay, a sharp change in direction.
Starts with an
Huh?
Does it start with an
It's like the limit is not the same.
F prime equals infinity.
Okay, well f prime equals infinity, the limits are not the same, so we could have like an asymptote, alright? Or a vertical tangent line, okay? So, f, now if f has a vertical tangent line, what's going to be true about the derivative? It doesn't exist, it's not defined. If f has an asymptote there, which it's not continuous, okay, or the derivative has an asymptote there, then the derivative is undefined, right? So we can kind of get both of those ideas here by saying f prime is not defined. So if you look at your derivative and consider the domain of x for the derivative, that will help you find critical numbers as well. Okay? Looking for specific values that would create an asymptote on your derivative shows you the values where the derivative is undefined, and hence it's not differentiable. F is not differentiable there. Okay? Now here, of course, you have a picture of both of these cases, f prime of c being 0, or f prime of c does not exist. All right? Let's actually look at an example where we would use this. Okay? So, we want to find the extrema of f of x equals 2x minus 3x to the 2/3 power on the interval -1 to 3. Okay? Now you can see the picture over here to the left. I'm going to move it off the screen so we don't cheat too much. Alright? And let's work our way through this and figure out what our solutions would be. Okay? So first of all, let's start with what we know. Take the derivative, okay? What is f prime of x? 2 minus 2x to what power? -1/3. Good. To the -1/3 power. Okay? Now, it might be helpful to simplify this one, because notice here, this would be 2 minus 2 over the cube root of x. The negative puts it in the denominator, the 1/3 is our cube root. Okay? So right there, I have my derivative. Now we need to consider two things. When we are looking for critical numbers, you need to consider two things. One is the domain of f prime. Okay? What is the domain of f prime? Is there anything x is not allowed to equal?
0.
Okay, anything else?
Negative.
Can you take a cube root of a negative?
Yes.
Yeah, that one you can do. But, sorry, I kind of trapped you. I asked that intentionally because I figured someone would say negatives. But it's a good thing to just remember, cube roots, odd roots you can take negatives, even roots you can't. So in this case we can do the negatives. X equals 0 is the only one. So guess what? That's one of our critical numbers. Okay, 0 is going to be a critical number. Now I know the left endpoint's -1, the right endpoint's 3. I'm not going to put 0 yet because I don't know where the other one is going to go. Or if there even is another one. Let's see. Okay? So I look at my domain to get one critical number. And then what's another way to get critical numbers?
When it equals to 0.
Yeah, when it equals 0. So I'm going to make 2 minus 2 over the cube root of x equal to 0. And we'll do a little bit of algebra here, okay? So 2 over the cube root of x is 2. And that means the cube root of x equals 1. Okay? So x has to equal 1 in order for my derivative to equal 0. Makes sense? So now I know my critical numbers are 0 and 1. So now I can put this here and this here, and now we can test all 4 of these points. Okay? Is there any question on what I've done up to this point, though? Want to make sure we understand.
Where did the 1 come from?
I solved this equation. Once we get down to here, cube root of x equals 1, we just cube both sides. And 1 cubed is 1. Okay, so now I am going to plug in these 4 values into f. Okay, so f of -1, f of 0, f of 1, and f of 3. Okay? Alright. So, what do I get when I plug in -1? -5. Notice here, if I do a -1 to the 2/3, that's an even first. If I square it, -1 is +1, and then the cube root of +1 is 1. So that's just a -3. And 2 times -1 is -2. So -2 minus 3 is not -1. Why did I write that? -5. There we go. -5. Okay? If I get 0, 0. Okay? 1, -1. Those are kind of nice. And the last one, you're going to need a calculator for. -0.24.
At the graph. There's a graph on the left.
Yes, there is. I was hiding that. Alright, so if you plug it into your calculator with a 3 in there, you can do that. By the way, remember, especially the more complex it is, if you use that STOX feature on your calculator, like if you do -1 store x, you can type this in with the x's and it'll evaluate it for you. Then you just type in 0 store x and it'll go back to the previous entry and it'll evaluate it again. You can do a bunch of them pretty quick. Or you could graph this and do trace and type in -1, then type in 0, type in 1, type in 3. Okay, but yeah. Alright, so now if we look at the graph that was given over here, we can see each of these values here. We have -1, -5, we have 0, 0, 1, -1, and 3, -0.24, okay? And then we can identify, even before we looked at this, we could identify the max and the min, alright? So our maximum is that point 0, 0, and the minimum is the point -1, -5. Okay, and again, you just look for the highest number and the lowest number out of the ones that you tested, and that'll give it to you. Okay? By the way, notice that 1, -1 was a relative min, but on this interval it's not the absolute min. Okay? Alright, any other questions? Okay. That is it. Yeah, just to revisit this for the sake of the video. This is the absolute minimum. This right here is a relative minimum of the function, okay? But when you're asked for the minimum on the interval, they're asking for the absolute on the interval. Okay, so you would give -1, -5. 0, 0 just happened to be both a relative and absolute. Max. Okay. All right. Yes.
So -1, -5 is counted as absolute minimum or relative minimum.
Absolute.
So if the minimum is 1, -1, then it will be relative minimum.
Yes. Okay.